Hi, are you listening? Sorry for not speaking Spanish, but I prefer to speak in English. My English is not so very well, but it's better than my Spanish. I will talk about how we are using OpenShift at SulAmérica and how a good CI/CD plan can save your life. I will talk about how we deploy a code before OpenShift and DevOps and after OpenShift. And I will show the size of our environment and our most used development stack. But first, I would like to introduce myself and SulAmérica. I'm a software engineer. I am currently leading two teams at SulAmérica. One is responsible for the web applications infrastructure, and another one is responsible for monitoring. And if the applications are running well on SulAmérica, I have time to run too. SulAmérica is an insurance company, as I said. We was founded in 1895. It's a lot of time. And we have more than 7 million clients in the whole country. Last year we had 20 billion in revenues. And our most important market is the health and dental insurance. And the car insurance is the second one. A little bit about our health insurance. We have 2.2 million customers. It is almost the Buenos Aires population. And last year, we did in OpenShift environment 16 million pre-authorized procedures and 7 million reimbursements. This is a lot of processing. What we are doing about digital transformation in SulAmérica? We was the first in Brazil to use machine learning to provide reimbursements without paper or without mail. And our app have 1.2 million users. About our second market, the car insurance, we have 1.6 million cars insured. And also on OpenShift environment, we did almost 18 million insurance quotes. This quote was the first project that we migrate to OpenShift. They usually run on legacy, and was one of the first projects that we migrate to OpenShift to gain scalability on that quotes. And in car insurance, we start to use telematics to discover the driving patterns of our customers. And with this, we can apply discounts for good drivers. Our goal is to influence a better driver behavior. And this actually works because people love gamification. They always want to win. And of course, they save money with that. All those slides with information of SulAmérica, I took from a presentation made for shareholders. This presentation is public, and I put the link here. It's public information. And highlights the importance of IT and the importance of technology in our business now. Was a time that IT was just a cost center. Now every company is a tech company. So we are a 120 years tech company. So we have a lot of things to do. From mainframe, our legacy applications running basically on WebSphere. And now we are in our journey to cloud. And this one is the services running on SulAmérica. We use Dynatrace. If you know Dynatrace, you know this image. And those are the Red Hat products that are helping us in this journey, especially OpenShift. So, a little bit of history. How we used to deploy a code a few years ago. The developer finished the code, and he had to open a ticket to us to deploy the code in production or development, whatever. So first, we have to discover if the application is new or not. And if the application already exists, we just enter on application server and deploy the code. This process took 1 day or 2, depends if you are busy or our ticket queue. But if the application is new, we have to create a new environment. So we have to work with the virtualization team for a new VM. We have to work with network team to get a new IP. Operation system team do the whole configuration. And after that, we can install the application server. And after a few years, we can release the code in production. I'm joking about the years, but this process took 2 weeks. It's a lot of time. And after OpenShift and DevOps, the developer finished the code, and they commit on Bitbucket, and Bitbucket automatically starts a trigger that calls Jenkins. I like Jenkins. And Jenkins do the whole work, checkout. We use Sonar and Quality Gate to code analysis and bug detection. After that, Jenkins also build the Docker image, build the app, and deploy on OpenShift. And after a few minutes, the application is ready to use. So we don't need to deploy codes manually anymore. So now we have to deal with the capacity of this environment. So the monitor team, also me, receives alerts about the utilization and the tendency of growth of the environment, and requires to my other team, the web infrastructure team, to increase the cluster. We work with the whole team that I already said, and increase the cluster. This process is still a lot of manual, but I worked for a while. I said worked for a while because our results of OpenShift was that we gain a lot of velocity. Now we don't have to wait until 2 a.m. to deploy a code, to deploy in production, because OpenShift have rolling deploy and other deployment strategies, so we can deploy in production anytime. We are delivering fast, minimum value products. OpenShift is microservice ready, but we also have a lot of monolithics running there. And what I think that was the most important thing that increased the environment was that now we can have a lot of environments for the same application. We can have development, testing, production environment. I said a lot of environments. Now we can test the different brands at the same time. So now we are creating almost 100 projects per month. So we don't use the term pods anymore. We call them gremlins because they increase almost every hour. So after that, with the growth, we decided to cut one layer. We decided to install OpenShift directly on bare metal. We decided that because we become big enough to occupy the whole blade, and we don't need one layer more. With that, we could reduce VMware license. We discovered that VMs are fat. A lot of resources of the blade are usually was used for virtualization, for operation system. And with that, we can put more containers per server. We gain performance too. One stud compared one application running on bare metal with the same application running in a virtual machine with the same configuration. And the application that runs on bare metal run 25% fast in CPU and I/O. It's not our stud, it's a market stud, but with few layers, the troubleshooting becomes easier. We don't have to analyze vMotion anymore. And with more containers per server and paying less license, we can reduce the total costs. Otherwise, the capacity planning can fail. We have to assure that we have capacity enough, because buy a new blade, buy a new server, and install it on data center is not fast, it's not simple. Servers sometimes go down, it's sad but true. And we have to be sure that we have capacity enough to assume the load. And with more containers per server, this becomes bigger because all the pods have to migrate to available server. So this is our sizing now. It's three weeks ago. Probably these numbers increase a lot. We have almost 1,400 projects and more than 33,000 gremlins running on OpenShift. We use 3 masters, 9 routers. This is still VMs because we don't need big machines to run the masters and routers. We have 10 production nodes. Those are bare metal with 32 cores and 256 gigs. We separate our environment with using node selectors. So the same masters control production and no production environment. We separate those with node selector. And we have 11 stage nodes mixed up between bare metal and VMs. And we have 2 infra nodes that run in logging, metrics, and other operational apps for OpenShift. And we started to use OpenShift 3.3, and now we are on the latest version, latest 3 version, not 4 anymore yet, 3.11. As I said, we have a lot of legacy that we just migrate to OpenShift, but the new application, about 90% of the new application runs on this stack. That is basically Java Spring Boot running under town. We use the Hikari, it's a connection pool, it's very fast, it's very good, the Hikari CP. And Senha Segura is a Brazilian company. It's a password vault to connect to database. We use Bitbucket as a source repository. The Bitbucket called Jenkins. Jenkins builds an image using Alpine Linux, a very small operational system. This image goes to Nexus, our image repository, and after that to OpenShift, our platform. We use the 3 HA proxies as routers. One is for intranet, the local connections, another for internet access, and the third one is just for API gateway that we use. Sensidia is a Brazilian company too. It's an API gateway. These routers send the traffic to the OpenShift routers that I said, the 3 clusters, and after that to the application running on OpenShift. We use Dynatrace for application monitoring. Splunk is more for security analysis. The security team uses a lot of Splunk. Prometheus for OpenShift metrics. And OpenShift comes with Elasticsearch and Kibana for logging too. And we have Happy Gremlins running there. What we learned over these 3 years that we are using OpenShift. Readiness and liveness problems are very important. This is the best feature that Kubernetes brings to guarantee the availability of the application. So you have to use readiness and liveness. Set up requests and limits. This is very important to the pod find the right node to fit. And OpenShift uses this to pod out scaling too. A tip is do some load tests to find the right size of your projects and pods, the right size of CPU and memory to configure the requests and limits. Node resource. We are using bare metal, and this is very important, especially if you are using bare metal, to reserve some resources to systems, to operational system, and to Kubernetes. The eviction policies is important too. Bare metal can deal with a lot of pods, have a number, a magic number, and it's good to configure the max number of pods running on each server. So Kubernetes arguments is our friend, use it. And this is what we need to the future. It's not fair to do a presentation of the session that we saw now, because almost that we want the OpenShift 4 will deliver to us. But we want to go multi-cloud. Our environment is just on-premise, running on bare metal, and we want to gain scalability running on different clouds. And with that, we have a better disaster recovery. If something happens on our data center, we can move to any cloud fast. And to enjoy what's the best of each cloud. If we want to use Vision on Google Cloud Platform, and we want to run an application beside the Vision, we can deploy a container there. Or if you want to use RDS, Postgre database on Amazon, we can deploy Kubernetes there. But for that, we need node.scaling. It's expensive to keep a machine, a AC2 machine, on 24 hours. So a good node.scaling it's important to better cost management. We are dreaming with service mesh. We have one specific case that we needed to do some kind of releases for different hospitals. And we have some hospitals that some features starts with this hospital, and do canary release with. We can do canary release now with OpenShift, but just for percentage or amount of traffic, and with service mesh we can do better canary release for just for one location, just for one state, one city, one hospital. And service mesh will help us with traffic management too and security. And we need to improve our infrastructure as code. This is very important. We do a lot of work manually yet. We use Ansible, and we do a lot of Ansible too, but have room to improve here, especially for self-healing the infrastructure. As I said, OpenShift have the readiness and liveness that is perfect for self-healing of the application, of the pods. But if a machine goes down, if a server goes down, we can use infrastructure as code. We can use Ansible for that. And infrastructure as code help for faster provisioning too. This was what I want to talk. And I will round here, and you can talk with me in Portuñol or Spanglish, what will be better for you. So thank you very much.